My name is Shahab, and I will be presenting the work that we did in Arizona State University with my colleagues Frank Liu, Alireza Bahremand, Assegid Kidane, and Robert LiKamWa. And our work is titled SWISH, a shifting weight interface of simulated hydrodynamics for haptic perception of virtual fluid vessels. Natural liquids exist all around us, and on a daily basis we interact with various types of liquids. The feedback that we receive from each and every interaction helps us in handling them properly. It stands to reason that bringing these sensations into virtual environments will help us in the future of workforce training and also education. In the emerging era of online education, students can go to virtual laboratories to mix acids and bases and experiment with chemical reactions. Bringing tactile sensations into these laboratories will transform the future of education. There has been a lot of work in virtual environments to render realistic fluids. But even though these liquids look real, they do not feel real. The chief characteristics of the liquids is that they take the shape of the vessel that they are in. When we pour water into a glass, the water takes the shape of the glass itself. As we start moving the glass of water around, fluid particles, water particles start moving around, subject to forces such as gravity. Also properties of the water itself, such as cohesion, adhesion, and contact forces with the glass itself. As we move the glass around, we can feel the center of gravity shift. That is obviously not the case with the current VR equipment because they have fixed center of gravity. But what if we could make it so? They would design vessels for VR and AR that could feel like they have virtual fluid inside them. And then we would make the center of gravity to shift, to make it so that they have volume and also viscosity. Prior work in this area has largely focused on rigid body objects. There has been work in providing tactile sensations of fluids as well. But most of these works have focused on using grounded devices, devices that users would have to go to interact with the fluids. Our work extends these works and provides an ungrounded device. The key idea behind SWISH is activating center of gravity, actuating center of gravity. With SWISH, users through the headset can see a virtual fluid. As they move the bucket around, they can feel the center of gravity of the bucket shift in real time in response to the movements of the bucket in their hands. In designing SWISH, we had 4 design considerations crisply in our mind. SWISH should accurately and quickly respond to the shift in the center of gravity. The center of gravity that is being calculated with the software. SWISH should service different volumes and viscosities of rendered fluids. SWISH should be made with off-the-shelf and easy to reproduce components, so the maker community can easily replicate it and make it to different sizes. So SWISH, finally, also should service the maker community to be able to reproduce it in different sizes for the different situations that they would like to experiment with virtual fluids. We achieved the spatial tracking of SWISH using HTC Vive VR lighthouses. Inside the Unity, we calculate the center of gravity of the liquid particles using Nvidia Flex. Our SWISH software driver converts the position of the center of gravity to the vessel center of gravity, and also converts those into motor commands. Motor commands are being sent via Bluetooth to the microcontroller. The microcontroller actuates the motors. Center of gravity shifts. At its core, SWISH has a novel 3 degree of freedom gantry system inside. We actuate the system using 4 motors. 1 motor at the bottom gives us the rotation. The 2 on the height give us vertical actuation, and 1 give us the radial actuation. At the bottom, we have a homing mechanism using Hall sensors and magnets, and at the top, we have a slip ring to make sure that the wires are not going to get tangled. What we demoed yesterday, and I've just shown in here, is the current version of the system. Designing this has been fun. The first iteration of this was quite literally a bucket, the biggest bucket that we could find in a hardware store. We drilled a hole at the bottom, slapped an EMA 23 at the bottom, put two more motors for the radial actuation and one for the rotation. It weighed somewhere around 12 kilograms. It was noisy, heavy, bulky, and slow, but it kind of worked. So it was fun, and we realized that the shifting of the mass is a phenomenon that we can explore. So we went back to the drawing board. This time we used DC motors. Instead of controlling the controlling mechanism of open, we used closed feedback loop system of PID, and that gave us accurate positioning of each and every motor, and we got to where we are. We chose 6 characteristic actions to evaluate SWISH: sway, swirl, pour, roll, jump, and saute. These actions were chosen. We chose them based on our daily interactions with liquids. For instance, when we have a flask and we want to know if there is any water inside, we sway that. We evaluated SWISH based on those actions, and SWISH was able to follow the path of center of gravity on those occasions with minimal latency and high accuracy. Analyzing those numbers also showed us that there are occasions that SWISH deviates from the path. In this case, you see that in the rotation, and that's because of the moment of the force around that axis. Later on, I'll be discussing our solution to it. We also evaluated SWISH using a user study. We asked 24 participants to interact with 3 identical buckets. The buckets were the same in terms of size, shape, and weight. The first bucket had real water in it. The second one had SWISH mechanism inside, and the third had solid weight in it, non-moving solid weight. We tested it using 2 various viscosities, simulated viscosities, one lower and one higher. Then we asked the participants to interact with each and every bucket and then rate the buckets based on the realism of the haptic simulation. Analyzing the results showed us that SWISH in every occasion beats the solid bucket. It comes close to the real water bucket in the lower viscosity simulation, and in higher viscosity, not only beats the solid bucket, but comes even closer to the bucket with real water. And that was kind of expected, because water cannot change its viscosity, but SWISH can adapt to programmable fluids. In the second user study, we asked the participants to pour the liquid contained in all of those buckets, in each and every one of them, into a graduated cylinder up to a certain point. Please note that the liquid is not actually leaving, but what they see is liquid leaving. But all of those buckets were contained and sealed. Analyzing the results showed us that, again, SWISH outperforms the solid weight bucket and comes really close to the bucket containing water. This actually surprised us because the mass is not actually changing. So what is happening? Well, it turns out that our work is actually supported by studies in psychology, that moment of inertia and also fatigue around the wrist of the users is helping us in creating this illusion of weightlessness. After this study, we asked the participants to answer some open-ended questions. Users found SWISH to be responsive, to be realistic in providing haptic sensations related to the experience that they had, to be smooth in transitioning from one location to the other, and also to be adaptive to various viscosities. Users also reported to some of the shortcomings of this system. When we made SWISH, when we chose DC motors over the stepper motors, we knew that the noise is going to be lower than before, but still, SWISH was noisy. And when you are in an environment that all you can see is a virtual environment and you don't have any headsets, those noises become more prominent. So users found that distracting. Also, to power up the bucket, we had wires coming into it, and that became distracting for the users as well. We designed this current version of SWISH to have a more pronounced mass shifting experience. That means that the mass inside had to be around 500 grams, and the entire system had to be big enough to create more moments around the rest of the users. That made the bucket to be a little bit too big, and some of the users found that to be distracting, because in those interactions they would have to hold the bucket with two hands, and that was not really easy. This motivates us to look into future development in this work. We are looking into various ways of dampening the noise and vibrations associated with the system. For instance, creating chambers around the motors or giving noise cancellation to the users. Also, we are looking into multisensory experience. Users reported that they preferred to hear the sound of the liquid itself as well. So we are looking into ways to have this multisensory experience to make this experience to be more pronounced. Also, we are looking into creating multiple vessel sizes. So users can hold the bucket in one hand and also have multiple versions of it. You could have a beaker in one hand, augmented with SWISH, and another one augmented with SWISH as well. And as you start moving your hand and pouring liquid from one to another, both of those would give you the sensation. We are also looking into ways to make the motors to become more efficient. I mentioned before that SWISH, even though successful and fast and accurate, was not able to follow the path in some occasions. More importantly, in the rotational axis. So choosing a motor that is going to have more torque, but with enough of a speed to give that sensation is one way to go about it. Also, when we reduce the size of the system itself, that is going to be helping us as well. So SWISH is our first step in creating vessels for virtual environments that can shift their center of gravity. Providing haptic sensations in virtual environments will transform the future of education. And our work is just the first step. And we're looking forward to have more work in this area. With SWISH, users not only see a real liquid, but also feel the liquid. Thank you so much.
All right, we've got lots of time for questions. So if the student volunteer can come up with the mic. In addition to the microphone, also passing out beads to incentivize questions, as is the session next door. So at the break, if you see people with beads, you'll know they are positive question-asking members of the community. Steve.
Okay, so this looks like really nice stuff. One of the issues, of course, is when you were pouring the water out or pouring the SWISH fluid out, it didn't really pour out, right? Which meant that you had a more equal footing because the water containing thing actually weighed the same amount at the end as at the beginning. So have you thought about how you would deal with something which really did appear to lose weight and mass as you poured stuff out of it?
Thank you. So there are works in open systems that you could add mass into a system if you need to, in order to change the mass in real time, and that has been explored. With the closed system, we have not found a solution that would give that sustained interaction or sensation that would feel like, oh, it's completely weightless. We have not found it yet, but I think that's the next step of the illusion for us, to find that sensation that would create that senselessness, that sense of weightlessness with a closed system that does that, and none of the moving parts would leave actually, but would give that. But it's not something that we have found yet.
Yeah, I can think of things with pulleys, for example, that were externally would support stuff and pumping
That's a great idea.
hydrogen or whatever into it, or helium. You know, that would not be a closed standalone thing.
That's a great idea.
Thank you.
Thank you.
Other questions? So I've got one while you guys think. There's beads on the line, remember? So you mentioned multisensory experiences. Can you comment a little bit about how much you think the haptic sensation is what people perceive over something like, you mentioned sound, but maybe there's also tactile of the liquid splashing, and you get maybe higher frequency haptic feedback, or even just seeing the amount of liquid in a bucket. So what role do you think haptics feedback plays when perceiving the position of water or movement of water?
So there's a difference between how we sense things. Of course, there's a difference in real life versus virtual environments. If we close our hands and we are having, and because of the numerous sensors that we have in our hands, we have a really close relationship with touch. Is that the case for virtual environment or not? Work suggests that visual dominance is something that is helping us. But at the same time, since we are short on providing these haptic sensations, creating an approach that has multiple things in it would emphasize that, would help with that. Now, which one has more contribution to it? My guess is that, again, in that order, haptic would be something that is definitely important, but I cannot say exactly would it be higher than sound or would be more important than even visuals. I can't really answer that. But to me, it's for every user that's actually is going to be different as well, because some people, and that was the case with our user study as well, some people mentioned that we actually wanted the sound so much and the others didn't really notice it to become something that was distracting.
Sounds good. We do have time for more questions. I see a hand.
I'm just wondering, is this the only design that you thought about, the kind of motorized center of gravity approach? I was just wondering, like, could you do, like, the best simulation of a physical phenomenon is probably the physical phenomenon. And then I was wondering, like, could you build a system where you basically change the viscosity of the liquid in there, and you could do something with, I don't know, balloons that self-inflate to offer more resistance or something. So is that something you experimented with and decided this is the better approach? Or, yeah, I don't know, other thoughts?
Thank you. That's a great question. So in terms of the mechanical system, then I'm going to answer your question directly. But in terms of the mechanical system, we experimented with delta systems, also with the cable-driven systems as well. But in terms of having something, for instance, some beads of magnetic particles that then you would magnetize to the side, and then you would have, because of the increased force, you would have that sensation. That's something that we're looking into in the future, because if we can create that, then it's going to give even a more realistic sensation. We have not found the solution yet, but that's definitely something that we're looking into.
All right, let's thank Shahab once more.
Thank you.